Welcome to the next lecture on multivariable calculus. Let me recall uh, whatever we have uh, seen in the last lecture. So far, we have seen that uh, if a vector valued function f uh, is differentiable at some point a, then there is a relation between directional derivative of f and the derivative of f at that point. So what was that relation? Let me write it. Okay. तो हम क्या मान रहे थे कि हम f एक फंक्शन है किसी ओपन सेट a से Rn में. Okay, so this A is an open subset of Rn. Let this be differentiable at a point A in A. If we have this, then all the directional derivatives of f exist, and f dash, this directional derivative is given by, okay. So we have further seen that if f is a scalar valued function, if f is a scalar valued function, if f is a function from a to r, scalar valued means it is taking values in r, okay, and say u be u1 u2 um in rm, अगर ऐसा है तो f dash au will be given by a linear combination of u1 u2 yeah, we have seen this. And you know what was that linear combination? That linear combination was this. So f dash au, this was del f by, say, let me call it d1 f a u1 plus dm f a um, and there, thus we concluded that this dfa is nothing but the gradient of f at point a. This is gradient of f. Let us see the same thing. So as I told you in earlier classes, that derivative of a vector valued function is given by a matrix. Okay, तो अब हम क्या काम करते हैं, उस मैट्रिक्स को ढूंढने का काम करते हैं. Okay, okay, मैट्रिक्स ढूंढने चलते हैं. For that, what we will do, we will consider a function f from an open subset A of Rm, taking values in Rn, and we assume that f is differentiable at A. Okay, let f from A to Rn, A is an open subset of Rm. Let this be differentiable. Differentiable at a point small a in A. Okay, our aim is to find expression for DFA, matrix DFA. Okay, find DFA. So since f is differentiable at a, ओके क्योंकि f डिफरेंशिएबल है तो हम क्या जानते हैं, हम जानते हैं कि एफ ए प्लस एच माइनस एफ ए माइनस डी एफ ए डॉट एच डिवाइड बाय norm h. This goes to 0 as h goes to 0. We know this. Now, this function f, this is a vector valued function. Okay, this means this function has fx can be written as component wise. Okay, so f1 is first component, fn is the last component. So this x coming from this is a vector in Rm. Okay, now assume take a equal to a1 to am, take h equal to h1 to hm. Okay, and consider or define f of h equal to fa plus h minus fa minus dfa dot h divide by norm h. Okay, so this expression will become, fh will become f1a plus h minus let me write first fa plus h. This will be f1a plus h, f2a plus h dot 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 fna plus h, correct, minus f1a fna minus dfa dot h divide by norm h. Let me write it here. Let me write it like this. This 1 by norm h. This is equal to this. Now what we do, we take h equal to t dot ej, where t is a real number and t is varying in r and ej is this vector of standard basis. Okay, so this is at jth place. So what we get from this after putting this thing in above equation, what we get ftej is, so I am putting this the value of h and a here. Okay, so h is now tej, so this will be let me first write, this is f1 a plus tej minus f1a. Okay, so what I am doing, I am writing this minus this minus the next one, this minus this. Okay, so this fna plus h minus fna minus dfa dot h divide by norm h. Oh, norm h is, let me write h is tej, so this is tej So here I did TEJ. Okay. So this. So DFA is a matrix. So DFA TEJ is TDFAEJ. Okay. So DFA of TEJ is T into T dot DFA dot EJ. What is this? This thing is the jth column of DFA. This is T into jth column of DFA. Correct? This means if DFA is say Bij, I running from 1 to n, j running from 1 to m, then what is DFATEJ? This is equal to T B1J BNJ. Correct? Okay, now what we will do, we'll write or we will write this value of DFA here. Okay, इसका जो भी एक्सप्रेशन है, इस जो भी वेक्टर ये हमें मिला है, इस वेक्टर को यहाँ पर सब्ट्रैक्ट करेंगे आप. ठीक है. ओके, आगे बढ़े. तो हमें क्या मिला है? हमारे पास हुआ लिमिट टी. नाउ यू सी, हमने यहाँ देखा था लिमिट ऑफ दिस एक्सप्रेशन इज जीरो बिकॉज एफ इज डिफरेंशिएबल एट है. और यह जो एक्सप्रेशन है इसे हमने ओपन किया इधर. ओके, इसका मतलब इसमें अगर हम लिमिट h गोज टू जीरो बोले, विच इज सेम एज लिमिट t गोज टू जीरो. ओके, so limit t goes to 0, this should be 0. Let me write it. Limit t goes to 0, क्या मिलेगा हमें? f1 a plus TEJ minus f1 a minus tb1 j. Okay, comma dot 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 comma fna plus TEJ minus fna minus tbnj divide by whole divided by TEJ. Okay, and this is equal to 0. What will we get now? So let me write this as, this is same as limit t goes to 0 f1 a plus TEJ minus f1 a minus tb1j divide by norm t. Norm Tj is t. Okay, let me write it norm Tj, then we will do this. This is equal to this thing. T goes to 0, fa plus TEJ minus fna minus tbnj divided by norm TEJ. This is equal to 0. So here this 0 means 0 vector. Okay. Now taking limit t goes to 0 through positive values. Taking t through positive values, what we will get? We will get what I'll do. Let me. So this means this is equal to 0, and all the components are 0. This is equal to 0. This whole thing equal to 0. All other components are 0. Let me choose one such expression. Okay. So limit t goes to 0 plus इसको नाम मैं देता हूँ एफ आई ए प्लस टी ई जे। मान लीजिए कि मैंने इस वेक्टर से ith ith कंपोनेंट में मैं काम कर रहा हूँ। यहाँ पर ith कंपोनेंट के साथ काम कर रहे हैं। सो दिस इज एफ आई ए माइनस टी बी आई जे डिवाइड बाय नॉर्म टी ej is t, norm ej is 1. Okay, this is equal to 0 for all I between 1 to n. Okay, so what will we get? We will get bij equal to limit t goes to 0 plus fi a plus tej minus fia divided by t, which is nothing but let me. So I have not yet completed because I have to show that this limit is 0, means right hand limit and left hand limit both are same. Okay, so this thing should be equal to bij for left hand limit also. Okay, now taking t to 0 through negative values. So what we get? Limit t going through negative values, this would be fia plus tej minus fia minus tbij. Now we are taking values t as negative values. Okay, so, and what is more norm tej? So here is norm tej. You know, norm tej is mod t norm ej. Okay, what is mod t? When t is negative, mod t is minus t. Norm ej. Norm ej is 1. Let me omit this. Norm ej is 1. This is equal to 0. So what we get from here? We get bij equal to limit t goes to 0 minus fia plus tej minus fia divided by t. Therefore, what we have seen that this limit and this limit, right hand limit and left limit, are same, bij, correct? Thus bij is nothing but limit t goes to 0 fia plus tej minus fia upon t. What is this? This is jth partial derivative of f at a. So partial derivative of f with respect to xj at the point a. This is del f by del xj at a. Okay. Oh no. Yes, it's okay. Uh, Let me write Fi here. Fi. And so uh, we have found entries of DFA. So what was entries? Entries are Bij. So DFA was given by this matrix Bij. This was an n cross m matrix. Okay, this was an n cross m matrix Bij, and its entries are this thing DJFIA. So this first one would be D1 F1 at A. Okay, so D2 F1 at A, DM F1 at A. Similarly, this would be D1 Fn at A, D2 Fn at A, Dm Fn at A. So here we have n rows, uh, m columns. So this is an n cross m matrix. Okay. So this matrix is called the Jacobian matrix. This matrix is called the Jacobian matrix of F at A. So therefore, what we have seen is if F is differentiable, then DFA is the Jacobian matrix. Okay? So remark, if F is differentiable at A or differentiable, then DFA is a Jacobian matrix. नाउ वन आप पूछ सकते हैं कि अगर डिफरेंशिएबल कोई फंक्शन है तो उसका डेरिवेटिव जो है वो जैकोबियन मैट्रिक्स है क्या हमेशा अगर किसी भी फंक्शन के लिए जैकोबियन मैट्रिक्स एग्जिस्ट करती है तो क्या फंक्शन डिफरेंशिएबल होगा ये हमारा नेक्स्ट क्वेश्चन है इसका आंसर नेगेटिव में है क्योंकि वी हैव दिस रिमार्क ओके लेट मी राइट ए रिमार्क यहाँ रिमार्क लिखते हैं existence of the Jacobian matrix, existence of the Jacobian matrix okay so इसका जैकोबियन हो सकता है किसी फंक्शन के लिए एग्जिस्ट करता हो लेकिन वह डिफरेंशिएबल ना हो ऐसा हो सकता है फॉर दिस हम एक एग्जांपल देखते हैं suppose f is a function from R2 to R2 f from R2 to R R2 to R defined by f is defined by f xy is this this is x square y square divided by x square y square plus y minus x square when xy is non-zero. This is 0 if xy is 0. What we will show that Jacobian matrix for this F exists. This means since in this case Rn is R, okay, since in this case Rn is R, this means gradient of F exists, but but f is not differentiable. Okay, so for this, let me first compute. Uh, Let me first compute. We first compute f dash 0 u, where u is u1 u2 and non-zero vector. Okay, so this would be limit t goes to 0 f 0 plus tu minus f0 upon t. This is same as limit t goes to 0. क्या मिलेगा आपको बताइए? This is t square u1 square t square u2 square. So this is t4 u1 square u2 square. Similarly, here t4 u1 square u2 square plus t square u2 minus u1 square. Okay, ये मिला. टी स्क्वायर कॉमन लेते हैं. टी स्क्वायर कॉमन लेने के बाद हम ओके एक 1/t और है हमारे पास. 1/t को यहाँ मल्टीप्लाई कर दीजिए. ठीक है, तो क्या मिलता है? तो यहाँ पर नीचे हमें मिलता है लिमिट t गोस टू 0. तो टी स्क्वायर कॉमन लेने पर हमें मिलेगा टी स्क्वायर u1 स्क्वायर u2 स्क्वायर प्लस u2 माइनस u1 स्क्वायर. T square into t is t cube. Okay, this is t cube. Here t4 u1 square u2 square. So you may cancel this t cube t4. So we will get this. So if u1 or okay, if u1 dot u2 is 0 means either of u1 u2 is 0, either of u1 comma u2 0. Okay, so in that case the limit is 0. Correct? If u1 u2 is non-zero, okay, if u1 u2 is non-zero, then what we will get? Okay, then we have to take two cases. In first case, if u1 u2 is non-zero and u1 equal to u2, let me take this. In this case, see here, this part will go out, this will be cancelled, so this is 0. Here I made a mistake, so this is square, so this part will get cancelled and it's 0. So we have this thing, so this will get cancelled, t by t square, so we will get 1/t, limit t goes to 0. So this means this limit does not exist in this case, does not exist. Another case is when u1 u2 is u1 not equal to u2, u1 not equal to u2, and u1 dot u2 is non-zero. Okay, so in this case what you will get? So this part, so in this case this is something this is something constant. Okay, and this part will go to 0, this part will go to 0. Okay, this is something positive, means non-zero thing. Okay, so it will again 0, correct? So f dash 0 u is uh, given by this. This means f dash 0 u exists. For Jacobian matrix, we need u to be we will take u to be even in one case, u to be e2 in another case. So d1f at 0 is f dash 0 even in this case. This is 0. What is d2f of 0? This is f dash 0 e2, again 0. This means Jacobian matrix exists. Jacobian matrix exists. Also, you see, this function cannot be differentiable as f dash 0 u is not defined. Okay, so in this case, f dash 0 u does not exist. So this means function is not differentiable. If this function would be differentiable, then all directional derivatives should exist. But in this case, there are several directional derivatives which do not exist. So this function is not differentiable. F is not differentiable at the origin because f dash 0 u does not exist for for u1 u2 such that u1 equal to u2. Okay, good. Here u1 u2 non-zero, so u1. So we have this term. So we have concluded that existence of Jacobian matrix does not guarantee the existence of differentiability. Correct? Okay, I'll stop here. Next lecture we will see continuously differentiable functions.